In this video, we're going to talk about resistance and resistivity. When we talk about pipes in comparison to wires, this is how we can determine something about the resistance or the resistivity. So how could the wire in a circuit affect the current? If a wire is like a pipe and the current is like water that flows through the pipe, well then, if the pipe is thicker or wider, you can get more water flow through it. So if the wire is wider, you could probably get more current through it or more electrons to move along it. If there were pipes with water in them, what could we do to the pipes to change the speed of the water? Or in the sense of electrical circuits, the current. Okay, we could change the cross-sectional area of the pipe. Making it bigger will allow more water to flow through it. We could also change the length of the pipe. Increasing the length will also increase the time it takes for the water to get to the end of its trip. So every conductor conducts electric charge to a greater or lesser extent. The last example also applies to conductors like copper wire. Decreasing the length or increasing the cross-sectional area would increase its conductivity. The inverse of conductivity is called resistivity, represented by the Greek letter rho. Each material has a different resistivity that depends on its atomic or molecular structure. Resistivity changes with the temperature of the material. Combining what we know about A, the cross-sectional area, L, the length of the wire or the length of the pipe, and rho, the resistivity, which is the inverse of the conductivity, we can find a conductor's total resistance, capital R. So here is your equation for resistance. Resistance R is measured in ohms. Remember that omega is the Greek letter that we use to represent ohms. The cross-sectional area is capital A. That has to be in meters squared. It cannot be in millimeters squared or centimeters squared. You have to have MKS units. Your length, L, is measured in meters as well. You cannot use centimeters and millimeters. You have to convert it to meters. Resistivity, rho, is measured in ohm meters. So what is the resistance of a good conductor? Well, low. Low resistance means that the electric charges are free to move in a conductor. What I'm going to do is I'll go ahead and put the link on the website for the simulation about resistance from the FET website. So here are some common conductors and their resistivities. Notice that all of these numbers are going to be multiplied by 10 to the negative 8 ohm meters. So silver is 1.59 times 10 to the minus 8 ohm meters. Tungsten is 5.60 times 10 to the minus 8 ohm meters. Platinum is 10.6. Notice nichrome is 100 times 10 to the minus 8 ohm meters. As you go down the list, the numbers get higher. In the next video, we'll talk about circuit diagrams.